Hello and welcome to Func Prog Sweden. Warm welcome everyone, and today I have a guest in the studio, actually presenting from Stockholm. So welcome. I'll head over immediately to the agenda. So first up there will be a short intro by me, Magnus, and then we'll head over to my guest in the studio, Intro to Swift for Functional Programmers by Adrian. And after that presentation, we'll head over to Polynomial Functors, Jackpot by Andre. So he will join us on link from Gothenburg. But first, I would like to thank our video sponsor, Adabeat. Adabeat is an IT consulting company focusing on functional programming. And if you want to know more about Adabeat, check them out on social media or on adabeat.com. Also, the coming schedule, we haven't set dates for August, September. However, we know that on 10th of October we will be IRL from Kivra in Stockholm. So if you're in Stockholm in October, please join us in Kivra. If you want to support the meetup community or Func Prog Sweden, head over to Meetup and join the meetup community. Or make sure to follow us and subscribe on the YouTube channel. And last but not least, also if you want to join in and discuss functional programming and the meetup today with other functional programmers, head over to our Discord server. You'll find the links and everything on the meetup or on the YouTube channel. As always, if you have questions during the presentation, just shoot them in the YouTube chat or on the Discord server. With that, we will start with our first presentation. Warm welcome, Adrian. Sorry, yeah, my brain got confused.
That's
two A's. Yeah, sorry. Adrian, warm welcome.
Thank you.
Thank you very much.
Swedish spelling, so I'm used to it.
Yes.
Cool.
Now we'll do the trickiest part in this presentation. I'll
Hardest
give
one.
Adrian the cable and we hope it works.
It's probably harder than with them also. But
Adrian will also do live coding, so we'll see how that works.
A little bit of live coding.
Yeah, a little bit of live coding. So,
yes, here we go.
Yay! Welcome, Adrian. The stage is yours.
Thank you.
You're welcome.
Yes. Intro to Swift for functional programmers, or you could also call it Intro to Functional Programming for Swift people, I guess. You know, you could flip those things around. My name is Adrian, or Adrian, or Adrian, or many other ways of saying it. I work as an iOS developer at. I'm employed by Blocket, but I work for Schibsted, you could say. Most of the things I do are for Schibsted, which is you could find me on Twitter and GitHub or everywhere else where my name is. And I happen to have seen one of the talks here, or many more, but one of the one which, let's say, inspired me to make one for Swift was Intro to Rust by Michael Snoyman, if I'm pronouncing it correctly. And I thought that Swift deserves a little bit of love as well from the functional programming community, since it is, there is many things you could do in a bit functional way in it. So here I am. Cool. So let's go to the first slide. What is Swift? Swift is a high-level, general-purpose, multi-paradigm, blah blah blah. But basically, it's it's a language made by Apple to replace Objective-C. So they had very, very ambitious goals with it because, well, you gotta basically convert your whole developer base, and that's quite a lot of people, to a new language. And one of the things they said, or it says on the swift.org, and I believe in some hidden forums when they all started it, was that they want to make programming simple things easy and difficult things possible. And this is a way to say that they have a thing called progressive disclosure they try to abide to, meaning that you could do simple things in it. And I mean, you could do things in it without knowing that much, but the more you know it, the kind of more complex it becomes. But my goal of it, like, if there is something you would take out of this talk, is that there is not much you need to know in order to start with Swift. And when you need those powers, you can reach them later on in your career. Yes. Second one. Why is Swift relevant to a functional program meetup? Well, Swift has immutable data structures, first class higher order functions, product and sum types, type safety, strong typing. That's not necessarily a functional programming thing, but it's highly valid sometimes. You have both lazy and eager evaluation. Eager, it's by default eager. You have quite powerful pattern matching, and much more, which we're not going to go unfortunately today in, but there is more to it. We have to start with a hello world because it's a programming language. So let's see how we do that in Swift. And I am gonna do a little bit of light coding, not too much. I have stuff. I'm gonna show you some stuff which is live coding, but it's not the main focus. The main focus is to understand the syntax a little bit. So that's how you write a hello world. And I'm now in Xcode Playgrounds, which you can it's the Xcode environment. Unfortunately, you do have to usually have a Mac when you're developing on Apple platforms. You can't really do that on Windows. That's the sad part about it. You can run it on Windows, but you can't really, it's not a thing to develop Swift on other platforms just yet. Not yet. Yes, so that was it. That's how you write hello world in Swift. And here we can see the actual output. So this is running code in Xcode Playgrounds. So one of the advantages is I could make a presentation straight into it, which is great. Yes. Moving on. We're going to talk about immutability. And I put optional in parentheses here because this is encouraged, but not, let's say, it's not like in Haskell, right? You have a choice to have things which are immutable and mutable. How do we define things which are immutable? Well, let, we say the name of the constant in this case, not a variable. We don't need to specify the type most of the time. So if I would say something like this, it would work just well. And this is a way, this is like one of the simplest things you could do in this language, and it's already immutable. I cannot change the data inside this constant because, well, can't assign, the compiler tells me what's wrong. Another interesting thing about this language is that it kind of encourages you to start with immutable things and then move to mutable ones. And I'm going to move on to structs, which are product types, which I'm going to explain later. But it's still interesting to take a look at them at this moment, because if I say something like, let's say, struct foo, bar, and let's say this is a string, if I try to make an instance of this guy, and I'm going to reuse a variable, and let's say that this is, again, foo, I cannot change this either, which makes sense because you have a let in here. But still, it's in most of the Apple tutorials, in most of the info you get on the most articles, or kind of the whole thing around the language is that you're supposed to have some sort of like you gotta start with structs. No one really knows why, but it's a thing. And I mean, I do have a hunch. Why is it so? The reason is because this language is trying to kind of nudge you into the direction of having value types over, have value semantics over reference semantics, and having immutable data over immutable data. That's very tricky to accomplish because the language itself set to replace Objective-C, which is a very dynamic reference, kind of referencey, or whatever you call it, kind of language. So it's quite a paradigm shift. But let's move on. So you have optional immutability. You can have things which are mutable as well with a var, and in that case, I would be able to change it. I need to make this a var too. But now we have mutability with value semantics. So now this works. Functions and higher order functions. Maybe I should have started with functions since we're in the functional program meetup, but let's look at the functions now. I'm gonna copy paste some snippets, so we have something to work on straight away. Or functions. Let's look at the syntax. Here we have the keyword, reserved keyword. We have parameters. We have the return type, and we have the body of a function. It's a C-based language. You can omit the return if you have a simple enough expression. And let's look at the next one. The next one is what we are interested in this kind of, the reason why we're here, to understand, I guess, higher order functions. What's a higher order function? It's a function which takes in functions, returns functions, or does both of those. And in this case, we can take in a function. So Swift does support that. And interestingly, it can support also returning functions. So here we have, you could call it, I guess, a curried version of apply twice. How do we use this? Well, you can call them with a number, let's say 5. You could also call it, you can pass in the function as a parameter. So notice that there is no, I don't need to expand on it. I just pass it in straight away, which is it's really handy sometimes. And you could also do this, pass in the 5 as a parameter. And now this is going to be, well, it's not a function yet, so I gotta, doesn't return anything yet, I meant. Now it's going to return something. So now we're using apply twice curried. So that's how you use functions in Swift. I would say it's pretty neat. You can do things which are a bit more usual to other functional programming languages, like maybe make here I made a closed range. Then you could map on it. You could pass functions like this, and you're gonna get the result. And you could continue on that, and maybe I don't know why this is not showing correctly, but you should have showed the right numbers. I guess it's because of the presentation size. But you could continue training on transformations, and that's where the feeling of kind of functional programming thingy from the language is coming from. It's slowly nudging you in that direction. Yes. There's another thing which Swift supports, which makes it friendly to functional programmers, and that's lazy evaluation. Lazy evaluation is, so by default, Swift is eagerly evaluated. So it evaluates whatever you have in here straight away. And even if you have like a huge array and there's some computation in it, it's going to evaluate it straight away. Let's look at an example. So for lazy functions, I have the, I guess, stereotypical is prime calculation. I mean, it could have been anything else in here. The only thing I cared about when I came up with this is that this takes a little bit of processing time, even on an M1 Mac. And I do define a range of numbers, immutable range of numbers. Not that it matters at the moment, but you could imagine not needing any of this. You could put all of this in like some sort of long, statement, kind of like ignoring all the variables or constants in this case. And the interesting thing to look at here is how this executes. So if I'm going to run it, it's going to go for the whole closed range of numbers. So here we have a closed range for a bit better visibility. This means basically all the numbers from 1 million to 1,500,000. And what it's going to do is going to go for all the numbers, filter it on this function, which takes an integer, returns a boolean if it's prime or not, and it's going to return me to us the elements which are prime. But let's say I only care about don't know, first one perhaps. Let's do that. If I would care only about first one, I would do primes, or maybe if let, which I'm gonna explain. First primes, and then first. If I do that, and then perhaps reference it, see what happens. It's still gonna go for the whole list, even though I only care about the first one. And that's not always what we want. Sometimes we just want, the first one, and we don't care about the rest of the computation. And Swift has opt-in laziness, and it's quite simple to use if you know about it. You just drop a lazy on the, in this case, the closed range. That's gonna make this computation stop, straight after finding the first element, which is also, I would say, quite important for some, for functional programming sometimes. That's laziness. I did promise I'm going to explain what is if let, and I will do that, I promise. But let's go to the next slide where you're going to have a little bit more of this. Here we go. Product types, sum types. Let's start with product types. Initially, when you start learning this language, you never really hear any mentions of what's a product type, what's a sum type, and in some way I think it's a good thing, because if you would start trying to understand it, of course if you don't have a functional programming background, which I didn't when I started learning the language, but it's interesting to think about it, about algebraic data types, and the reasoning for that, at least for me, it was that I could make impossible states, like states which should be impossible at compile time, which is something which Swift excels at as well, because the compiler here is quite helpful sometimes. But let's look at a bit more, perhaps theoretical, but I would say quite neat example. So if I would go back to my bag of tricks and pull out a new trick, I'm gonna pull the one which is gonna say product types. Here we go. So what are product types? Product types are a combination of our types, I would say, and the combination is basically how many instances of that type you could make. And the reason why I decided to add this in the presentation is because I thought it would be quite interesting to look at this from for perhaps some people which see Swift from a new angle, let's say, like this. We can have, if we have a product, and these guys are generics here, and we define those generics as booleans, there is 2 by 2 states you could have. And the reasoning is that, well, you have true, true for the first one, you have true, false for the second one, and you end up with true, 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 false, 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 true, false, false. And that is 2 by 2 equal 4. That's all the possible ways you could make this product when generalized with booleans possible. Another interesting thing, I would say, available in Swift is called void. And void in this case does allow you, so it's not the same as in some other kind of functional programming languages, like in Haskell, from what I understand, it does not let you instantiate anything. Like it's just like a empty void. Here it is kind of, it does let you make something with it. So I can generalize product on A and B, and I can make the second generic type a void, which still allows me to instantiate it. So that gives us true, false, and in both cases we don't have any choice but put void in here. Now the most interesting one, which the whole the whole mystery is getting revealed here, I would say. There is a type which most Swift programmers I would suspect never seen, just because you cannot not do anything with it. It's called never, and I have not seen this myself for for a really long while until I happened to catch this explanation from some other people explaining, okay, never corresponds to 0. And I was like, why? Well, you cannot make anything with never. And never, if I generalize product with a boolean never, kind of nullifies the whole thing. Like, it maps to the algebra which we had in school, in simple algebra which we had a really long time ago. Like, you cannot make a product type with a bool and a never, because a never cannot be made up, and nullifies the whole thing, and it's kind of like a 0. So that's where it starts to make sense. If you can map this to math. My math teacher would have never believed I would ever end up explaining this to anyone. So I'm quite surprised myself, but that's basically a way to look at it. Some types are similar, but here we have addition, because you could either have something on the left or something on the right. And we're going to do the same exercise of deriving what we can do with this. And let's look at the first example. So first example, it's a bit tricky to, it kind of tricks us a little bit, because we have the same result. You have 2 plus 2 by 4, it's 4, and before we had to multiply by 2, it's 4. So it's kind of same number. I mean, why should we care? I mean, if we follow the things we can do, we end up with true false for the left case, we end up with the true false for right case, and that is indeed 4 cases we can make this sum with. But here where it gets a little bit more interesting, since we can have either left or either right as we can stick some values into it, and this is our associated types. I forgot to mention that. You can stick values into your enums, and you can pass them around. Then you end up having left, true, false. Right one can be only void. There is nothing else you put it in there, and that's 2 plus 1 equal 3, which also corresponds to the simple math we had in school. And the last one, 2 plus 0 equal 2. And I guess you could see by now where this is going. We cannot have anything in here. It just does not work. And since we have only 2 types, 2 instances of this type, we end up with 2 plus 0, because we cannot do anything with the right one, and that is 2. So that's a bit of an intuition, and I guess for people who have done quite a lot of functional programming, this is maybe quite basic, but it's still interesting to look at. I do hope there is some people which have looking at Swift from a new angle today. And why this matters? Well, you can argue a lot why it matters and why it doesn't. What I like about Swift, it does not lock you into this from the beginning. Like, this is not knowledge you need to know in order to use Swift. Like some other languages out there, they kind of guide you along. You can do a lot of stuff without understanding any of this, and that's kind of a benefit of a language. I'm not saying it's the only language which does that, but I think it does it well. And as I said before I moved to pattern matching, one of the reasons why thinking in terms of product types and sum types is interesting is because you can make impossible state. You can define that on the code level rather than doing a lot of if else, maybe that or maybe this. There's an example. There's a really interesting example in URL session, which I'm going to steal from a resource. If we would pass in a URL request, we would get a data, a question mark, URL response question mark, error, and then this is a closure or like a function. But the interesting thing is that you can have an optional data, optional meaning that you might have data or might not have data. You might have an URL response, you might not have an URL response, and you get an error as well. And it's maybe now you see that there's something wrong with this. Like, what if you have data and you have error at the same time? I mean, that's technically possible. But if you think about modeling your I mean, data model, you could call that. You could call it like that. Then this kind of stuff might not be. You make it impossible at compile time because you could stick here in a sum type and enum. And this is Apple's APIs, and I'm not criticizing them. I'm passing around the, just observing things which are interesting. As I said, I did take this example from a very interesting resource I highly recommend, algebraic data types from Point 3. That's where I first saw this stuff, and I highly recommend people checking it out. And I'm going to have this talk on GitHub later. You could check it out. But let's move to pattern matching now. So pattern matching is one of the things in Swift which Swift is known for. I don't think we have. I mean, there's so many ways of pattern match in Swift that it would take a whole talk in itself to do that. So what I'm going to do is just to do the simple ones, or simplest version of it, and then one of the more complicated ones a bit later. So if we would switch on a sum, we could. Switching on a sum means that we go either left or right. In this case, because we only have 2, or first, second, depends how you take it. And we just follow what the compiler says. We can bind to the values, to the associated values, and do something with it. Perhaps just reference it, and we could maybe ignore it here because we don't care. And ignoring it is done by saying break. That's basically how you would do that. That's pattern matching, super simple pattern matching. There's a little bit more complicated pattern matching, which I'm also going to just paste in because it's tedious to write all of that. And that would be, let's see, 5th. Pattern matching point. You can pattern match on an expression, or like it's called expression pattern matching. This is a tuple, which is also a product type. You can have anything in here. You could put a string if you want. And in this case, we're pattern matching on the tuple itself, and we're saying, okay, well, what if it's 0, 0? In that case, we reach this branch of code. What if it's in this range? So you're pattern matching on a range. That's I don't know how many languages can do this, but I would suspect it is a little bit of a. I mean, depends on what you look at. Of course, there's way more powerful languages, but it's still interesting that Swift has this, and I think it had it from the beginning. When it was released in 2014 or 15, I think, was one of the first versions. Yeah, so that's pattern matching. And error handling. Let's move to error handling. Error handling takes multiple variations in Swift. There is kind of 2 ways to do it. There's still no clear path, which one is the right one. People kind of mix and match sometimes. And I would say the first one to look at is the one where you throw from a function. So if a function happens to say that, okay, I could throw this error, which is the network error. Here we just, have some boilerplate to make something happening on the screen. And the way to deal with this is you need to open a do catch syntax. So you have do catch like in some other languages out there, and then you're gonna call your throwing fetch, and then here you could say some URL. The interesting thing is that compared to some other languages, or compared to most of the other languages which have this, I'm gonna comment this out, which have this syntax, these guys do catch, they don't unwind the call stack, meaning that it kind of treats this throws as a return from the function itself. So this is basically a return under the hood. So it's not like it's quite performant to do this kind of stuff. So you shouldn't be afraid of it if you do it in Swift. It is though a little bit. It infects your code if like you need to short circuit it at some point, and you do need to have. So Swift is very like strict about what you can do. So you do need to specify throws if it's actually gonna throw. So it can just randomly throw an error from a context which cannot throw an error, and so on and so on. So that's the interesting thing about this language. But let's see what we get here. Do we get an error? Now we got an error. Now we got an error again. The bull god today is sending us errors. Let's look at the unthrowing version of fetch. You can pass errors as embedded in a sum type in this case, and the way to do that is, well, you could see it on the screen. You just have a bool random, then you embed it in a success, and then you can put it into a failure as well. So that's just basic error handling in Swift. This version, I do prefer it a little bit more because you stay in the land of types, I guess you could say like that. But it is tricky because, I mean, I think it's a matter of preference. It's just that both of these ways, they don't support accumulating errors as far as I know. So you wouldn't be able to pass in like a result of array of errors like this. There is some libraries which are trying to fix that, and one of them is validated from the same .3 co people I mentioned before. So yeah, there is ways to handle errors in Swift. You're not going to be full of errors if you use this language. And I guess one more interesting to mention is that you don't need this syntax. You could also do this, which means that I don't care if this fails or not, unless I need the value. And then this is going to turn out as an optional value, and here I need to unwrap it. But if I don't unwrap it, if I don't unwrap it, then I'm going to have it just as an optional type, which means that it can be a nil, a string or a nil, which makes it actually another way you could argue of error handling, because it could have a nil or it could have a value. But that's very similar to what the result is giving you. So I guess it's the same type of error handling. It's just that optionals are, one more way to do it. You could also force unwrap, meaning that this would crash at runtime if it happens to be an error, if it happens to throw an error. This sounds a little scary, but sometimes you might actually want to do this if you're loading, I don't know, assets from a disk and you don't want your application to work. It cannot work without those assets or something like that. So it has many ways to handle that. And that was error handling. Should we move to the demo? I think we can move to the demo. The demo is going to try to apply all of the say tricks we learned, and hopefully all of them are going to be used. Meaning, like you can see, it was really daunting to try to make a statement for this language. You could say that in like less than 1 hour and try to prove it that it's interesting from a functional programming point of view. Or maybe you could flip that around and for someone who's just doing Swift to look into functional programming. And the demo itself is not that focused on functional programming. It's just the usual Swift code. But it does keep in mind some of the principles, like, I don't know, keeping the data separate from the mutations and so on. But that's just a general thing in Swift, I guess. So what are we going to do? I took the, we have the NASA API. I'm going to look at some pictures, hopefully, if we get to them. And I took a chance to model the response we might get from NASA. The response is going to have an explanation, which is string, string, string. Coding keys are a way to specify, to kind of like, if we get the JSON back in a form which is not the way we want it to name our types in Swift, because we would want to use a camel case in here, we would do this, basically. Say, okay, I have a coding case and a string, and whenever you see this one, actually match it internally to this representation. And decodable is a protocol. Protocols, we're not going to get into protocols today, but protocols are, you could call them interfaces in some other languages. They're a bit different. It depends on which language you're compare it with, but it's a way to extend the language. And I mean, some protocols are provided by Apple or by the foundation, by Swift itself. But you can extend the language in a way that you feel that it makes sense for your use case, and it would be for the language itself, it would not make a difference if that's your protocol or if that's something which was coming with the language itself. So it does not have a lot of compiler magic. I mean, it does have compiler magic, but you can play with it in a way. You could define your collection type, for example, your own custom collection type, and it would behave exactly the way as any other collection type in Swift does. And that's done through protocols, and that's a way of composing functionality in it. I did not mention that, but yes, this language also likes to do composition over inheritance. It's also a thing from the ground up, which is also something which might be interesting from a point of view of functional programming. But let's go to the demo. I've been talking too much. Yes, what do we have here? I'm going to paste in some boilerplate, because no one likes boilerplate. And that's some way to do decoding in Swift. Fetch data and decoding. Don't get scared of the amount of code. It's just the presentation mode makes it look a lot more than it is. But there's also a way to make this simpler, but we're gonna get into that later. Let's see how we fetch some data. We pass in an URL. We return the result, which can be data or error. This guy is provided by Foundation, which is part of Swift Foundation. Then we're going to call URL session, which is also a thing provided by basically the Apple platform. I guess it's everywhere. We're going to return a success, and then we're going to catch if we get an error. We have some new keywords here, which I'm not going to go again into it fully, or I'm just going to say a few words about it. You can do structured concurrency in Swift since, I believe, 2 versions ago they implemented it. I'm not sure exactly which one, but this is a new thing. So, and it's not similar to what you would imagine it looks in languages like, I don't know, JavaScript. It's a little bit more like Rust, meaning like they try to bake it in the same philosophy of like trying to make things impossible at compile time. So we would, that's like a very short intro of what async await is. And it is a way to do asynchrony. So that's I guess that's also a way to say what async await is. We're gonna decode some the response, and the way this works is, since we marked this guy as decodable, then we can decode it, and it does not have to be JSON. It could be some other stuff as well, as long as there's a way to send it through, like in some sort of form which is not code. And we tried to decode it. Well, we got a success. We got a failure. Then here we're going to create an image. And the UI image is something provided by Apple as well. I mean, everything here is provided by Apple, but it's part of UIKit, which is a framework for developing apps on iPhones, macOS, and well, AppKit for macOS, but you could use it still. Okay, let's do something now. Then let's do some coding. So we need to fetch some data. We have URL up top. Let's see what happens. Well, it tells me that I need to await it because I'm in a context which does not support concurrency. And And now it works. And we got a success back. And all of this is live. The stuff you're seeing down here shouldn't be too scared of. This is just Xcode being Xcode. It does work actually, but we are way behind the other IDs out there, but we gotta work with what we have. What can we do next with it? So let value maybe. We got an data in there. What can we do with it? Well, we can pass functions like this. And I guess, what should I do with this one? We have a data. We need a way to transform it and get something else. Maybe I should pass the decode response, which I have right there. And I do pass it point freestyle, and I think I'm gonna get some result. Hopefully. And we have a double result. And so most of the people which have seen, I don't know, have seen this kind of stuff before and already the answer. We actually need to flat map on it, and that's gonna flatten the structure. And now we have a result of response and error, which we want in this case. And just to make sure that it does what it does, yes, we have a success and we have some data in there, and Xcode is complaining, but we're going through. Let's switch on this. Switch on the value. We have a success. We're binding to the value, and in this case, the response. And let's see what the response has. It does give us an HD URL, which in this case is a string, but yeah, we're not gonna handle errors because, well, don't know. I've not seen a live demo of anyone handling errors, so I guess I'm gonna keep the the tradition. What can we do next with this? Well, we have let's assign it to a variable, or constant in this case. HD URL. We have an HD URL. It does complain because I need to, I think I need to make it a computed variable. Well, we don't really need to do this actually. I don't know why I'm going that direction. I'm just trying to do things in a bit different way, but I guess we could just go straight here. I'm gonna fetch the data yet again from the URL. Let's make the URL itself. So as I said, Swift is very, very particular about what you're passing it in. If you pass like a string to something which wants an, like we want to make an URL in here, and it is gonna complain. It's not gonna let you do that because, oh well, that's an option. Here we have to have an exclamation mark, meaning that if this initializer fails, this is gonna crash. We could also just not do that and just unwrap it, and that's gonna give us like a safe path to it. And now we have an honest URL. But since we're doing a live demo, we don't really care about that, so we're just gonna force unwrap it because we know we have an URL in here. And that's the next thing. We fetch the data again, and here we're gonna have some result, result. Let's see what we get, and we need to do await yet again. I believe this should work now. Here we have result of data in there, and hopefully that's the image somewhere inside. I think, maybe. No. I have no idea, I haven't clicked on that, but now I clicked on it. So that was it. That was a longer version of doing it. I could also show a shorter version of doing it without all of this code. There is a way to do it, which it would have been really hard to read for someone who's seeing it for the first time, and that's basically that version. You don't need a lot of code to do things in Swift. That's my main goal for this talk, to try to explain that this language is not doing anything, like you don't need to know much of it to do things like this. That's me, yet again. You can find me on Twitter, GitHub, LinkedIn, and everywhere. I have some references I want to share with you. Swift by Swift, structure concurrency as well on swift.org, I believe. Collection types is one of also the highlights of this language and what you can do. Point3.co for people which are interested into functional programming and Swift. And with this, I think I'm done.
Thank you very much, Adrian. Thank you. Very nice presentation. We had some questions in the beginning, like are list collections immutable type? But someone else, Gabor, answered it. It depends on if you assign it to a const or a variable.
Thank you, Gabor.
Then we had a shout out also. I'm surprised by the functional support in Swift. Cool stuff from Douglas.
Thank you.
So I think you managed to convince someone.
That was the goal. I wasn't trying to do anything, complicated. It was interesting to see the other talk about Rust from the functional point of view, and I thought that it would be interesting to do the same for Swift, and I think it deserves a little bit of attention there.
It does. It does. It's really nice.
Cool.
Yeah. How come you came into Swift in the beginning?
I mean, that's like,
was it just a coincidence?
I don't know. I think I think I was one of the victims of progressive disclosure. Like you can do simple things with, like you do things with it which do not require a lot of knowledge, but then, the deeper you go into it, you have to...
You learn more and more as you progress in your career.
Yeah. Sometimes you learn things you don't want to learn about. There's a funny thing about Swift. It's like simple, but it has... I think it's top... I don't know exactly which... what number is it, but I know it's top languages in amount of reserved keywords.
Ooh.
So, like, there is so much in it, which, like, someone who has seen this language 5 years ago and you would still he or she would still understand what I'm doing here, but going into like a real project, people would feel like, oh, that's a different language. There's a lot of you could argue in both ways. It's a good thing, it's a bad thing, but it's lets you do things as I prove to you, hopefully, without knowing much. But if you want to do more complicated things, you could do that as well.
Yeah, cool. How come you come into functional then? So you started out learning Swift, and then, like it said, took one step at a time, and then at some point you just unraveled or or stumbled.
I think it was a happy accident. You could call it happy accident. Like as I said, I have never been like a big math kind of person, or like someone who would care about mathematics in school or in general in life. But I think when I saw once that you can, the things I've been doing in programming up to that point, you could simplify them in a way that you could provably you could have like a pattern for how you could do things in a way that actually makes the code a little bit make more sense. And there's like a rule set around that, and there's some guys in like 70s who figured out all of this stuff before you. It kind of like, I was like, okay, that's interesting. And then I started looking at the programming itself a little bit different way, because now I can look at my my own code, and there's things I'm doing in it which now I'm doing in a bit different way, because I'm thinking about all of this. Okay, should this be even possible to write, right? That's something which comes from functional programming. It does push you into, I don't know, I would say in a better way of designing software. Not always, but
no. I kind of agree. My own career in software development was starting elsewhere and then ending up in Erlang. And then once I learned Erlang, or functional programming, Erlang, and then functional programming, really start seeing coding in another way.
It's one of those things people come into functional programming, but they don't leave it. Like
it's the end.
No, I mean, like
the end state.
Yeah, I mean, you come into it and you're like, okay, maybe you get it, and no, you get it, meaning like you like what's happening in it, like the way you build stuff.
Yes.
You don't feel like dropping that after you know it. That's what I mean.
Agreed.
It's a good thing. Not always, because sometimes it's a little bit verbal, sometimes it's just not what you want. But if you would talk in general, it gives a little bit of aesthetics to what we're doing.
Yeah. Again, thank you very much for joining us, Adrian, and for your presentation. We'll put out the links, as Adrian mentioned. We'll put them out below the video and in meetup, so you can find it there also. for those who are interested in your presentation. And once we put it out on GitHub, we'll share the link there also. Of course, again, thank you very much, and thanks for your participation.